Students, in this video, we're going to talk about writing a molecular equation, ionic equation, and net ionic equation after mixing the cobalt 2 bromide with sodium phosphate. Okay, so before we actually do that, we want to make sure we're able to write down the cations and the anions and be able to be able to write down the reactants formulas and predict the products eventually. So in this case, cobalt 2 means I have a 2 plus charge on the cobalt, and the bromide means I have a bromide is a 1 minus. Okay, so sodium is 1 plus, and phosphate is PO4 3 minus. So this is going to be CO right there. This is cobalt 2 plus. When I put it together, the cobalt 2 bromide is going to be COBr2. And then when I put the Na1 plus and PO4 3 minus together, it's going to be Na3 PO4. Okay, so because remember you have to balance out the charges, so you must have 3 sodiums to bring in a total of 3 plus charge that would balance out the 3 minus charge. Okay, when it comes to predicting the product, you always want to say that your inside ions stays inside and then your outside stays outside. So the cobalt gets combined with the phosphate and the sodium gets combined with the bromide. And then you can always go back and double check with the ions that you have broken down on the top here. So CO2 plus, the only other possible anion it can combine with is going to be the PO4 3 minus. Obviously, it's not going to combine with the Br minus because that was already in the reactants. Okay, and then the only other possible, and for the Na1 plus, the only other ion it's going to combine with is the Br minus. So that's how you're going to be predicting the products if you don't want to use this inside-outside rule. Okay, now let's write it down. So when Na1 plus gets combined with the Br1 minus, it's just going to be NaBr. Okay, and then what about when the CO2 plus gets combined with the PO4 3 minus? So when a CO is a 2 plus charge and PO4 is a 3 minus charge, so that's going to be the CO3 PO4 2, because you would need 3 cobalts and 2 phosphates to have the charges, the positive charge and the negative charge, equal to one another. So you must make sure your positive and negative are balanced by one another. Okay, once you predict the product, you want to write down the phases of those. And like I said earlier, these reactants are mostly going to be in aqueous, and you can kind of double check. The bromine and the bromines are actually going to be soluble in water, and the bromides are not soluble only when they are either with silver, mercury, or lead. All right, so that's your rule 2 in the solubilities I have posted in another video. So this is going to be an aqueous, and then the Na3PO4. Sodium is in rule 1, that's an alkali metal ion, so it does not matter what anion you have, as long as you have this first group metal, those compounds will dissolve in water, so that's going to be an aqueous as well. The NABR, it's got, again, the first group metal. The first group metals compounds always dissolve in water, so that's also going to be aqueous. And the cobalt phosphate. So remember the rule for the phosphates, most of the phosphates are insoluble. The only phosphates that are actually soluble will be if they are bonded with the alkali metal cations or the ammonium cation. All right, any other cation you see is going to be insoluble. So this cobalt 2 phosphate is actually going to be the solid, so I'm going to write down S for that. So that's the driving force for this reaction. Then, once you predict your products, you want to make sure you balance out the equation, and it seems like I have everything imbalanced right now. I got 3 sodiums on one side, I have 1 sodium on the product side, got 2 bromines on the reactant side, and I have one bromine on the product side. So maybe pick one of these elements to be balanced first. And in another video I have posted, I've said one of the trick you can always use balancing equations, pick the highest subscript. Okay, and the highest subscript is the sodium and with the cobalt. So let's try to go with the cobalt first. So cobalt on the product side is the highest subscript. It's got 3 on it. So maybe try balancing that first. So since you have 3 cobalts on the product side, I have to go back onto the reactant side and see what I can do to make 3 cobalt. And seems like it's an easy fix. I can put 3 in front of cobalt 2 bromide, and that would make 3 cobalts on the reactant side. Okay, so that takes care of the cobalt. And then what else I want to take care of? Okay, how about taking care of the bromines now? Well, as soon as I put 3 in from the cobalt bromide, that makes it 6 bromines on the reactant side. So I need to have 6 bromines on the product side, and to make 6 bromine, I would have to put 6 in front of NaBr. Okay, so that takes care of the bromines, and then let's look at the sodiums now. After putting 6 in front of NaBr, I have 6 sodiums. Now I need to go back and make sure I have 6 sodiums on the reactant side, and right now I have only 3. So that means I need to put 2 here. So that makes it 6 sodiums again, 6 sodiums on the reactant side. And while doing so, now I have 2 phosphorus. All right, so there's 2 in front of sodium phosphate. We have 2 phosphorus, but when you look on the product side, there are actually already 2 phosphorus and 8 oxygens. And that's what you really have on the reactant side as well. So once you balance few elements, the other elements automatically adjust in the balanced equation. So this is going to be your balanced equation. So that's your molecular equation. Okay, well, after writing the molecular equation, it's time to write the ionic equation. So when you're writing the ionic equation, you have to break down all the aqueous into the ions and leave the solid as it is. So let's start from the reactants. So let's writing the ionic equation. So I'll have 3 CO2 plus aqueous, and I have 6 Br 1 minus aqueous. Then I have, when you look at sodium phosphate, there's 2 in front of it, so make sure you take that into account. So that's going to be 6 Na 1 plus aqueous. And then you have 2 phosphates, so 2 PF4 3 minus aqueous. So those are your reactants. Okay, so that's going to go ahead and make the product. So let me just write down the products on the bottom here. So your NaBr on the product side is also aqueous. So let's break that down into the ions. So that's going to be 6 Na 1 plus aqueous. And that's also going to be 6 Br 1 minus aqueous. And now your cobalt phosphate is the solid, so you don't want to break that into ions, so leave that as it is. It's going to be CO3 PO4 2 solid. Okay, well, this is going to be your ionic equation, and when you're writing the net ionic equation, you have to go back and cancel out any common ions in the ionic equation. So net ionic equation would involve only the one that does not get canceled out. So let's see what the common ions we have in the ionic equation. So we got 6 bromides on both sides. So I got this bromide right there and 6 bromide right there. So those are going to be your common ions on as one of them. The other common ions you're going to have would be the sodiums. So both of those are going to cancel out. So once you do that, you are left behind with 3 CO2 plus aqueous. plus 2PO4 3 minus aqueous, and they get combined to make CO3 PO4 2 solid. So that's going to be your net ionic equation, and whatever has canceled out are going to be your spectator ions. So your spectator ions are going to be the sodium 1 plus and the Br 1 minus. So spectator means they are just the audience. They don't do anything in the equation. Your net equation is the other ions making a solid product. All right, so hopefully that video was helpful, and I post some more questions and I'll solve those in another video.